Okay, so I'm Mike Smith, and today I'm going to be talking about Pixelprof, which is a new way to infer galaxy profiles quickly. I did this work while visiting Queen's University, Canada, and I'm a PhD student at the University of Hertfordshire. So how would we usually measure a surface brightness profile? You would take a galaxy, you would take an observation of a galaxy in one of the spectral bands, and you would fit isophotes to that galaxy. You can think of these just as contour lines where the fluxes along the isophote are roughly the same around it. And you would fit those, and you would take the median pixel value for each of these isophotes, and you can get a 1D function which describes the brightness of the galaxy as you radiate outwards from the center. Now, there's several problems with this method. You need a human in the loop. So you need someone to identify the galaxy center. You need someone to remove the sky background, mask out any nuisance foreground stars or satellite trails or stuff like that. And finally, you need someone to correct the final isophotal fits. So you need someone to uncross any cross isophotes. You don't want to be double counting fluxes. And this takes time. You need a human in the loop. You need someone babying the algorithm, as it were. So how would we automate this out? And you can think of galaxy profiles as natural language captions. They can both be encoded as a list of floats or integers. So words, you can think of that as a vector in dictionary space or something. And obviously, your surface brightness points are floats in of themselves. They both have a length and content dependent on the conditioning image. So there you've got the galaxy. You want to produce the surface brightness profile from that, or you've got a picture of a dog in a river. And they both need to terminate once the sentence or the profile is complete. So if you think of them as natural text captions, you can leverage NLP methods developed specifically for captioning natural language, natural images. So you could use something like an encoder-decoder network. This is just a ResNet CNN encoder. It encodes it down, the galaxy down to a latent space, Z. And its latent space is passed towards a recurrent neural network. Here we have a GRU. And a recurrent neural network, in a natural language system, it would produce a sentence, but here we train it to produce the surface brightness profile. And it's fast. So classically, you could have someone inferring the galaxy profiles, a full day's work, you might get 150. The Pixelprof method can infer one profile per second on a Xeon CPU, to within a tolerable error of 0.38 mags per arc second squared. And it's entirely automated, so we can just throw as many CPUs as we want at it. It goes through all of the galaxies quickly, and it can infer 24/7. A Xeon doesn't need to sleep or eat, it just goes. And it's the equivalent of having 180 trained astronomers running the old method constantly. So let's just conclude. We applied a encoder-decoder model to approximate a semi-manual galaxy fitting pipeline. The approximations are close to the training set, and the approximation is calculated over 2 orders of magnitude faster than the old method. And yeah, if you want to know more, please email me at that email, and that QR code will link to my poster.
Thank you very much, Michael.
Okay.
Round it up,